Welcome back, fabulous fifth graders. It is time to start multiplying with decimals. So you will think that multiplying with fractions, and we had talked about how easy that could be by just multiplying the numerators and multiplying the denominators. You are going to find out today that multiplying decimals, again, assuming you know your multiplication facts, is as easy as multiplying fractions. I'd even go with a smidge easier. So we're going to just start by reviewing how we multiply with whole numbers, and this is something that we have done since, I would go with maybe September. So let's do a quick review here. So we have 385 times 24. So we always start off by writing our numbers stacked on top of each other vertically and lining up those place values. Ones place on top of the ones place, tens on top of the tens, and then we just go through and we multiply using the standard algorithm. Our ones, and then we'll go to our tens. So 4 times 5 is 20. Bring that 2 over because we can't put it all in one place value. 4 times 8 is 32, plus the 2 we carried over is 34. How important are your math facts, huh? 4 times 3 is 12, plus 3 is 15. And we are done with our first partial product. We're going to cross those off, and we're going to move on to our next digit, the 2. 2 times 5 is 10, put our 0, carry it over here. 2 times 8 is 16, plus that 1 carryover is 17. And that 1 over there. 2 times 3 is 6, plus 1 more is 7. Again, knowing your multiplication facts is really going to help you here. And then we can just add up our two partial products. And we are at our final answer. 9,240. You can also think about some rounding, right? We've talked about friendly numbers and how they will affect how we think about things too. So this is pretty close to like 400. And then we can even say like 24, we can round it to 20. And if we're thinking about 400 times 20, kind of quickly mentally, we're thinking about like 8,000. And this is our estimate. I don't want us to get confused. That's pretty close to 9,240 overall in general, using front-end estimation. We could always estimate a little bit further with a tens place, but for our purposes, that's pretty good. So that's always a good check. That will come in really handy when we're talking about the decimals because of that decimal place value. And we'll jump into that in a minute. So let's kind of move on. Hopefully that was a nice, easy review for you. Let's talk about how we're going to multiply with decimals. So multiplying with decimals involves the same exact thinking as multiplying with whole numbers. So if you're a little rusty on multiplying whole numbers, I strongly suggest you practice that before jumping into decimals. When we're multiplying with decimals, we're basically going to pretend that the decimals aren't there for the moment. And we're going to shift our numbers to become whole numbers. I'll kind of tell you more about what that is in a moment. So you would then, once you have your whole numbers, you're completing the multiplication as you normally would. And then because you shifted at the beginning, you shift back at the end, the same difference that you would need to kind of break even. So you kind of pretend that the decimals aren't there by shifting our place values over. And then once we've multiplied, when we finally had our final product, we end up shifting those place values back in. So remember, we've talked about how our place values are always on groups of 10, and so every shift we make is a power of 10. We've also talked about how at the end of every number is a decimal. So that's why that shift to the end of a number is going to work out in our favor here. So let me show you what I mean, because I'm sure that's a lot to think about without an example in front of you. So let's look at this example. 3 45/100 times 3. Okay, so I had said let's pretend the decimal is not there. Let's shift it to become a whole number, and then we'll shift it back. So what do I mean? Well, I'm thinking about 3 45/100. All right, so we're going to, I'm not sure what happened there. So we are going to go right. So 3 and 45 hundredths. And we need to shift that to become a whole number. So I'm going to shift it over. Let me change colors here. 2 place values to the right. So I'm shifting its value, kind of like multiplying it by 100. And I'm now going to have 345 because I did a double shift. So I'm going to take my 345 and multiply it by 3. Keeping in mind that my real number is still that 3 and 45 hundredths times 3. Okay? So I'm going to pretend that it's not there. So I'm doing a double shift. I've shifted it twice. So I have 345 times 3. 3 times 5 is 15. Bring my 1 over. 3 times 4 is 12. Plus 1 is 13. Bring my 1 over again. 3 times 3 is 9. Plus 1 is 10. All right. 345 times 3 is 1,035. However, we now need to take those numbers that we shifted, those place values that we shifted, and shift them back. So now I'm going to take my decimal, which I know is always at the end. All right, and we know that our decimal is at the end of our number. So we are going to take our decimal, and we're going to move it 2 places to the left, because I'm now decreasing my value back again. So I had increased it 2 places to the right by 100 to get to 345. And now I need to take that back into account and decrease it by 100 so that I can have my reasonable answer. So if I do that, my new answer becomes 10 and 35 hundredths. And that is the answer to this problem. So you find your answer, but then you have to put your reasonability into it. So we shifted the numbers once, and then we shift them back to kind of account for us pretending that the decimal wasn't there. And this is why I was talking about earlier about the estimating and how it becomes so important when you're working with decimals. So if I estimate, I'm going to estimate up here. If I estimate 3 and 45 hundredths to 3, and then I'll keep 3 as 3. 3 times 3 is 9. 9 is reasonably close to 10 and 35 hundredths. So I know that I've placed my decimal in the right spot. So that's going to become another critical piece when you're looking at these questions to kind of help guide you. Okay? So again, I shifted 2 places to the right at the beginning so that I could pretend that the decimal wasn't there. And then I multiply as I normally would with my whole numbers. And then at the very end, my answer is not 1,035. I have to account for that shift. And so I'm counting it back and shifting it back over to 10 and 35 hundredths. All right, let's look at another example, a real world example. I still have Taco Tuesday on the mind. So we have a taco place, and I'm ordering some tacos and an iced tea. So this is where you're going to be using this in real life. If I want 3 tacos and they are $3.25 each, plus my iced tea, how much is that going to cost me? So I'm going to figure out $3.25 times 3. And I'm thinking about how this is really going to be 325 times 3, right? So I'm going to be shifting my decimal over 2 places to the right so that I can think about my problem really being 325 times 3. And if you're good at pretending it's not there, you don't have to write it twice, but if you prefer to write it twice, sometimes it kind of helps frame your mind a little bit. All right, so here we go. 3 times 5 is 15. Carry your 1 over. 3 times 2 is 6, plus 1 is 7. 3 times 3 is 9. Now, I am not going to be spending $975 on tacos. Come on now. I love tacos, but I don't love them that much. So we're going to go back to our idea of the fact that we shifted our number. So we need to now shift it back. So we know at the end of every number, whole number, there's a decimal. We don't typically put it there, but it's there. and you can add on as many zeros as you want. So shifting that $3.25 to $325 kind of was like multiplying it by 100, shifting it over the decimal to the end of the number. Now I need to shift it back, like dividing it by 100. Important that we always remember our place values, right? So I'm going to shift it back 2 places, and now I'm at $9.75. Now, all right, you're talking $9.75 for tacos. All right, that seems a little bit more reasonable. Now, don't forget, I'm also going to be adding in my iced tea. So that is $9.75 plus I'm now adding the $2.25 of the iced tea. So remember, it's kind of like with fractions, strangely enough. When you're adding and subtracting decimals, you have to line up the place values. Whereas multiplying, you're not worrying about it because you're shifting your place values. But I will say, like fractions, you have to get the common denominators when you're adding. So it's a little bit more tricky. I find that interesting that adding and subtracting decimals and fractions is more complicated than adding and subtracting, or than multiplying fractions versus decimals. All right. So we're going to add up. So we have 5 plus 5. I'm just going to squeeze this in here. I apologize if it's a little sloppy. 7 plus 2 plus 1 gives me another 10. And then we have 9 plus 2 plus 1 gets us to 12. I'm running out of space here. All right. Excuse the mess. So my total ends up being, I'm going to just write it over here, $12. Right? And is that logical? Tacos about $3 each for about $9. Iced tea is about $2 more. That gets me to about $11. So yeah, $12 seems like an accurate amount. I'd be willing to pay $12 for some delicious tacos. Now I'm getting hungry. All right, let's do one more example before I let you go, and then you'll be free to try your own. All right, let's do another one. Let's go to Red Robin. A little different than I think the one at Patriots Place. But we're going to be ordering a couple different things. So we're going to order 2 orders of Texas chicken, because that sounds delicious, 3 side salads, and a Whiskey River ribs. All right, so let's start off with the 2 orders of the Texas chicken. So the Texas chicken is $6.95, and we're going to order 2 of them. So $6.95 times 2. Now, I'm just going to try this without, I'm thinking about my shift, but I'm just going to leave it there for now. So $6.95 times 2. 2 times 5 is 10. 2 times 9 is 18, plus 1 is 19. I'm just ignoring the decimal. 2 times 6, sorry for the bad 6, is 12. Plus 1 is 13. Okay. And then now I can kind of think about, oh, well, I would have shifted the decimal twice and rewritten it. Instead, I kind of took a shortcut. So I'm going to take that same idea and shift it over twice. And so my orders of chicken ends up being $13.90. Was that logical? Well, $6.95 is about $7. 7 times 2 would be about 14. Yeah, that makes sense to me. All right, let's try the next one. So 3 side salads for $1.25 each. So I'm already thinking 3 times $1. My answer should be somewhere around 3. All right, let's see here. We'll use some green. $1.25 times 3. And 3 times 5 is 15. I need to get better at my spacing. 3 times 2 is 6, plus 1 is 7, and 3 times 1 is 3. Put our shift of our decimal, so we're counting shift twice, and we're going to shift it twice again, 375. That is logical. And then we're going to add them all up. So we're going to add our 3. All right, and if we add up all of those pieces, our chicken, our salad, and our ribs, we end up with $25.60, which is not a bad deal. Sorry for my messy writing. To plan better with my writing. All right, so in conclusion, we have that multiplying is the same process as multiplying with whole numbers. You just have to account for the shift. So shift to the right and then shift to the left at the very end. Thank you so much for listening, and please feel